In this video, we'll see how to compute areas under the standard normal curve using the TI-83 and 84. To do this, we'll need z-scores, or standard units. So we'll assume that if you had some x values, you've already converted them to z-scores. So let's say we want the area under the standard normal curve between -1 and +1. This corresponds to the probability that z is between -1 and +1. To find this on the calculator, we're going to go to second vars, which is distribution, and then normal CDF. So we'll go to second vars, and normal CDF is number 2. The C is for cumulative because we're finding the area over an interval. We don't want to choose the P for point probability. So we have normal CDF, and it wants a lower bound and an upper bound. So if we draw a little sketch, it helps us visually see the lower bound of interest is -1, and the upper bound of interest is +1. So this is going to be -1, and this will be +1. So here, to enter it into the calculator, we can either clear this number that's the default, or we can just type right over top of it. So -1, enter to get to the next line. Upper is 1. Leave mu and sigma as 0 and 1. So hit enter, 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 and then enter again to get what we expect. We're going to expect about 68%, right? So here we get it as a decimal, 0.68. So let's call this 0.683. Now let's do number 2. We want the probability that z is greater than 1. So a sketch is really helpful so we can see about what to expect. Here we can see our answer is going to be less than 50%. If we get an answer greater than that, we know we made a mistake. So visually, we can see that our lower bound is +1. But what's our upper bound? We don't really have one. We want everything greater than +1. But we need to pick an upper bound to enter it into the calculator. So what z-score can serve as our upper bound? We want to choose a very, very large z-score like 5. Because remember, we're talking about standard units, so a z-score of 5 is really big. The area under the normal curve to the right of 5 is going to be negligible. So if we choose a z-score of 5, which is going to be out here, then we won't really miss out on any of the area. So in general, when we're doing a greater than, we'll be okay to use an upper bound of z is 5. So let's go to second vars and go to normal CDF. And we said our lower bound here was 1, and our upper bound, we're going to choose 5. So we'll enter 1, enter 5, enter, and we get about 16%, which is what we expected. So let's call that 0.159. Now, for number 3, we know what to expect. This area is going to be the complement of this area. So these two will add up to 1. So here, what will be our lower bound and our upper bound? The sketch shows us that our upper bound is 1, and our lower bound needs to be some negative number over here. So let's use a z-score of -5 as our lower bound here. If we do this, again, we won't miss out really on any of the area. So upper bound is 1, lower bound is -5. So let's go to second distribution, normal CDF, lower bound is -5, upper bound is 5, upper bound is 1, and we get the complement of this. So let's call that 0.841. Now, just to convince you that the area under the normal curve to the left of -5 over this way is negligible, let's do it. Let's go second vars, normal CDF, lower bound is negative, some huge number, and the upper bound being -5. What is the area under the normal curve to the left of -5? So times 10 to the -7. So put 6 zeros here, and you can see that's a very tiny number. So to 3 or 4 decimal places of accuracy, using a lower bound of -5 in this problem is fine. Okay, so to do this on the TI-83 is similar. We're going to go to second vars, normal CDF. Now here you have to enter the lower bound and upper bound separated by a comma. It doesn't give you prompts for lower and upper. So if we wanted to do number 1, we would just do -1, comma 1 right there, and then hit enter. So similarly for number 2, to evaluate this on the 83, we would go to second vars, normal CDF, and then do 1, comma 5, and there's our answer. On the TI-83 or 84, there's a second way to get these answers and to draw the corresponding graph. We can go to second distribution and then over to draw and then do shade norm. Enter the lower and upper bound here. Let's enter -1 and 1. Now this is nice, but if you haven't chosen an appropriate window, you're not really going to see the normal curve. You'll still get the answer though. So the area, here's our answer, corresponds to the area. If we wanted an appropriate window, we would want z-scores on the horizontal axis, so we might go from -5 to 5. We have density on the vertical axis, so maybe we'll just do something like this so that we can see the curve. And then regraph, and that's a good window for the normal curve. But if you don't remember to set that window, or if you have other plots on, they might interfere with this graph. So using shade norm is a little problematic for that reason. So I would recommend in general using normal CDF. Okay, so using your calculator, now try problems 4, 5, and 6. Okay, so we'll show you how to do it on the 84. We'll go to second vars, number 2. This is a less than, so draw a little sketch. We want to the left. So our left endpoint is going to be some negative z-score like this, -5. And our right endpoint is going to be this upper bound here of -1.5. So here's our answer. 0.668. For the second one, we'll go to second vars, and we'll do 1.5 as the lower and 2.5 as the upper. And we get this. And for the last one, second vars, normal CDF. 4 is our lower bound because we want to the right of that. So for our upper bound, we're picking the large z-score of 5. So we expect this answer to be pretty small. So when you see this 3.13, don't write that down as your answer. These are decimal answers. So you can't have an area bigger than 1 or a probability bigger than 1. So this wouldn't make sense if we wrote 3.13. So don't forget to see this e to the -5 over here. That means this is a tiny number. So we have to move the decimal place over 5 spots. 1, 2, 3, 4, 5. So we end up with 4 zeros. So we have 0.1234314, let's call that. That's it for this video. If you liked it, give it a thumbs up and subscribe below.